Stan Jabalisco here to explain the frustrating and all too common phenomenon of dead spots with wireless routers. Just about everybody who uses a wireless router has experienced this phenomenon, and there really isn't a whole lot you can do about it except to get the best possible router that you can. But here is my connection as I have it. Here's the internet. A cable connects to the modem supplied by Mid-Continent Communications. They claim that I can get up to 100 megabits per second download speeds, and on occasion I have in fact observed download speeds that great under ideal conditions, but usually it's more like 40 to 50 megabits per second with a direct connection to a computer. But I don't want to have to bother with direct connections to a computer for a number of reasons. So I got a wireless router, and this thing is made by a company called Linksys, which just about everybody who has a router probably has heard of this company. It purports to be able to transfer data at a speed considerably greater than the 100 megabits per second that Mid-Continent Communications provides me. I have 3 computers that I typically use. Actually, 4 computers that I typically use. One of them is located right next to the router. I mean, it is like 3 feet away from that router. And it always gets a 5 out of 5 in the signal strength. I haven't shown that computer here. Maybe I should just draw that in. It's right next to the thing. These little symbols, by the way, these little goofy looking little symbols are antennas. In the case of the, well, they receive and transmit both ways, these antennas. This computer always gets a 5 out of 5. This is a computer that I'm using right now. It's upstairs above the router, maybe 10 feet away, and it gets a 4 out of 5 usually, sometimes a 5 out of 5. Then I have 2 computers down in the basement in the nerd cave. One of them gets a 5 out of 5 even though it's, well, it's about 10 feet away from the router, and the other one is about, maybe 20 feet away from the router, and it usually gets a 3 out of 5, sometimes only a 2. Well, the interesting thing about this is these are all, except for the Surface Pro 2 right here that I'm using to make this video, all of these computers are fixed in their location. I can't move them around. So, I mean, I could move the computer over a few inches, but be a major pain. Now the Surface Pro 2, on the other hand, I can move at will. Well, there's some interesting stuff going on here. Why such a large variation in signal strength amongst these computers, even though none of them are very far away from the router? I mean, the router is supposed to be able to work up to, what, 100 feet or something like that? Nowhere near that. But yet, in some specific locations, particularly with this Surface Pro 2, I have noticed dramatic drops in the signal strength that seem to occur in just little tiny zones. Those are dead spots. Why did they happen? Well, when you have, actually I don't get that phenomenon very much with this router for a reason that I'll outline in a bit. But a lot of routers, they operate on a single frequency. Let's just say, I believe one of the frequencies is 2.4 gigahertz. One of the wireless router frequencies. It so happens that a radio wave at that frequency is 300 millimeters long. That is just about a foot. If you move a router a fraction of that distance from, if you move either the computer or the router a fraction of that distance, you might get phasing effects that can produce a dead spot, because not only do you get the signal going directly between your router and your computers, but because of all of the house wiring that you have, All of the metallic objects in your house all act like little reflectors of radio waves, and they all conspire to create an enormously complicated phase jumble of waves all through your house that sometimes add together to give you an extremely strong signal, and sometimes they just happen to cancel each other out to give you a weak signal, and those distances can be as close together as half of this 300 millimeters, which is 150 millimeters, which is only a little over 6 inches. I could move this computer 6 inches, and if I was experiencing a major dead spot, I might notice a difference between a 1 and a 5 on the signal strength meter that every one of these little computers has. You know, those little bars kind of goes up, and you see how many bars are filled, how many bars are whitened. So how do you get rid of this dead spot phenomenon? Well, you really can't. You really can't. If you only have, not unless you have a more sophisticated router like the one I have, which helps. This particular Linksys router operates on 2 frequencies, 2.4 gigahertz, and according to the specifications, 5 gigahertz as well, which is a wavelength of only, pardon me, I got that wrong. That wavelength is only, I got this wrong too. This wavelength is only 125 millimeters. And this wavelength is only 60 millimeters. 125 millimeters is maybe, gee, just 4 or 5 inches, something like that. You'd move these computers just a couple of inches, and theoretically you could get this dead spot phenomenon. I'm sorry for that little error, but that's just sometimes the way it goes when you get old. The crucial part here, though, the part that I'm trying to get at, is that these dead spots are pretty common, and the only way you can really get around it if you have that problem is to move your router slightly, relocate your router. The antenna, the 3 little antennas on this Linksys router, you can kind of tweak them around, you can move them around. It's kind of neat, but the real gist of solving the problem lies in the use of multiple frequencies. Unfortunately, 2.4 gigahertz is just about exactly half of 5 gigahertz. 5 gigahertz is just about exactly twice 2.4 gigahertz, so these frequencies are almost exactly harmonically related, which is not a good thing for dead spots. It gives rise to the possibility that both of these frequencies could experience a dead spot at the same time, although it's a lot less likely that you'll have dead spots on 2 different frequencies at the same time as opposed to just one. Ideally, these frequencies would not be harmonically related. That is to say, maybe 2.4 gigahertz here and 4 gigahertz there, or 5 gigahertz there and 3.2 gigahertz there, something like that. But we have to take what the Federal Communications Commission sees fit to give us for our wireless frequencies. You might even someday encounter a router in the future that has 3 different bands, 3 different frequencies, meaning that you would have 3 different waves, and if only one of them gets through, you get a good connection. So the chance of having dead spots is a lot less with a multiple frequency router than it is with a single frequency router. And this Linksys is so far I'm happy with it. I've had it for a couple of months. I've heard some complaints about it overheating, but I sometimes wonder when people put these components near each other, like for example the modem and the router. Don't put your router on top of your modem. Don't put anything on top of anything else, because the heat from one will rise and cause the other to get hotter than it normally would, and perhaps hotter than it should, especially on a hot day. Locate your equipment in a well-ventilated, cool area. give all of your equipments here plenty of ventilation, and they should work more reliably for you than they would if you let them overheat. Now that's just common sense. But that's the reason why you encounter dead spots. It has to do with radio wave phasing. Sometimes the radio waves reflected from all of these different places in your house, as the waves go all over the place and bounce off all sorts of things, you get little zones, little spots where they will cancel. But that's a lot less likely with a multiple frequency router than it is with a single frequency router. So I hope I've helped you out a little bit with all of this stuff. My rule of thumb in regards to routers and modems and things like that is get the best. I mean, why get something less than the best and then have problems and wish that you'd gotten the best? Go ahead and get the best. And I think that this Linksys is just about the best. I forget the model number. It's EA5400 or something like that. So far, so good. Maybe I'll be eating my words in a couple of weeks when that thing catches on fire. But, you know, I guess everything can malfunction, you know, now and then. You're going to get lemons now and then. But so far, I've had good luck. Hope that, like I said, hope that helps you out a little bit in your quest for the ultimate wireless experience. Stan Gibilisco signing off. Until next time, so long.